In this video, we're going to begin our discussion with exponents. So exponents represent repeated multiplication. So this 3 to the 4th, well, the 3 here is what is called the base of the exponent, and the 4 is the exponent, or the exponential power. So 3 to the 4th can be written as 3 times 3 times 3 times 3, which is 81. X to the 5th is x times x times x times x times x. Now, I want to show an example. Okay? Negative 2 to the 4th power. That is the same thing as negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. 4 times 4 is 16. Now, this, where the negative is not inside the parentheses, that's the same thing as negative 1 times 2 to the 4th. And 2 to the 4th is 16. So 1 times negative 16 is negative 16. So be careful. In parentheses, negative 2 to the 4th power is not the same thing as negative on the outside 2 to the 4th. Okay, so I'm going to ask you to simplify x to the 3rd times x to the 4th. Well, let's expand this out. So x cubed is x times x times x. X to the 4th is x times x times x times x. So we have 1, 2, 3, 4, 5, 6, 7. So this is x to the 7th. Now, notice the base stays exactly the same. Now, how did I get the 7? Well, what basic operation can I put in between the 3 and the 4 to get 7? Well, that is addition. So this is what is called the product rule. If you have a to the m times a to the n, that is the same thing as a taken to the m plus n power, where a is a real number and m and n are integers. Note, the product rule can only be applied if the bases are the same. Okay, so let's simplify a couple of these examples. So we are multiplying two expressions here. Well, the 6 times 7, that's 42. That stays the same. This is h to the 1st times h to the 5th. That's h to the 1 plus 5 power. J cubed times k, which is the same thing as 42 h to the 6th, j to the 3rd times k. Okay, let's take a look at the next example. So I'm going to start again with the coefficients. Negative 5 times 2, that's negative 10. This is m to the 1 plus 2 plus 1 power. So then n to the 4th times n to the 3rd times n to the 1st. That's n to the 4 plus 3 plus 1. And I can simplify that to be negative 10, m to the 4th, and n to the 8th. Okay, so now let's talk about x squared taken to the 3rd power. Well, I can expand this out as x squared times x squared times x squared. So when you multiply exponents with the same base, you add the powers. 2 plus 2 plus 2 is 6. So this is x to the 6th. So notice you're taking an exponent power to another exponent power. Well, what basic operation can I put in between the 2 and the 3 to get 6? Well, that is multiplication. So this is what is referred to as the power rule. So if I have a to the m taken to the nth power, this will be a to the mn power, where a is a real number and m and n are integers. Notice the base has not changed. The only thing I'm doing is I'm multiplying the exponent powers together. Okay, so let's take a look at a couple of examples for this. So first off, I'll take 3 to the 4th, because remember, this is 3 to the 1st. 1 times 4 is 4. So x to the 5th taken to the 4th power. That's x to the 5 times 4. This is y to the 6 taken to the 4th power, so I'll take y to the 6 times 4 power. And I can do something similar with z, z to the 7 times 4 power. Well, 3 to the 4th is 3 times 3 is 9, times 3 is 27, times another 3 is 81. This is x to the 20th, y to the 24th, and z to the 28th power. Now, I can use this power rule even for fractions also. So this 2 is to the first power, so 1 times 2, so that's 2 squared. This x is to the first power, a power to another power, you multiply, so that's x to the 1 times 2. Y taken to the 3 times 2 power. Now do the same thing in the denominator. That's 5 to the first, 1 times 2, that's 5 squared. This q has an exponent power of 1, so that is q taken to the 1 times 2 power. And then r taken to the 2 times 2 power. Okay, so let's simplify. 2 squared is 4. That's x squared, y to the 6th. Divided by 25, q squared, and r to the 4th. Okay, so now I want to use multiple exponent rules to be able to simplify. So when I see this, I'm going to have to take something to the second power, to the third power, but then notice I got to also multiply. Well, order of operations tells me I need to take care of exponents first, so I'm going to do that. So this is 3 squared. When I take an exponent power to another power, I multiply. 4 times 2 is 8. Power to another power, I multiply. That's y to the 10th. This is 2 to the first. 1 times 3, that's 2 cubed. This is x to the 9th. And that's y to the first, so 1 times 3 is 3. So 3 squared, that's 9. Remember, 3 times 3. X to the 8th, y to the 10th. 2 cubed, 2 times 2 is 4, times 2 is 8. Okay, so now I can multiply. 9 times 8, that's 72. Remember, when you multiply exponents with the same base, you add the powers. So 9 plus 8, that's 17. So that's x to the 17th. 10 plus 3 is 13. So this is y to the 13th power. Okay, let's take a look at the next example. So again, I have multiple exponent rules that I'm going to use here. So let's do that. So I'm going to rewrite the negative 2x. This is x taken to the 6th. That is x to the 6th. When you take an exponent power to another power, you multiply. This is 9 to the first. 1 times 3 is 3. So that is x to the 9th and y to the 15th. Okay, so let's simplify then. That's negative 2x times x to the 6th, y to the 24th. 9 cubed is 9 times 9 times 9. That's 729. X to the 9th and y to the 15th. Okay, so multiply the numbers normal. That gives me a negative 1,458. Remember, when you multiply exponents with the same base, you add the powers. This is x to the first, so 1 plus 6, which is 7, plus 9, that is 16. So that's x to the 16th. And then 24 plus 15, that's 39. So that is y to the 39th power.